If we make contact with extraterrestrial life, I think in this century, we'll probably pick up signals from an extraterrestrial civilization. For as long as space exploration has been a thing, we've been trying to figure out if we are truly alone in the universe. As we have learned more and more about the planets in our solar system, it's always been pretty clear that no one else is out there. But what if that's just our solar system? That's a question the entire world asked the first time we made contact with Oumuamua. And, well, in a surprising turn of events, it's back. Michio Kaku just announced that Oumuamua has returned, and something weird is happening. Join us as we unveil what's really going on and what all of this might mean for the future of Earth. In 2017, astronomers made an extraordinary and groundbreaking discovery when they detected an object named Oumuamua. This particular finding turned the world of science upside down because of one key factor. Oumuamua was the first known interstellar object to traverse through our solar system. It was a massive deal because it offered scientists a once-in-a-lifetime opportunity to study a celestial body originating from outside of our solar system. Until its detection, astronomers had primarily observed and studied objects within our own solar system. And even in that, we have a lot of things to discover. The arrival of Oumuamua presented a completely new category of exploration, allowing researchers to gain unprecedented insights into the properties, composition, and dynamics of objects that originate beyond our immediate cosmic neighborhood, something that we could have only dreamed about just a few years ago. To say that this was an unprecedented find would be an understatement. Why? The exploration of Oumuamua held tremendous importance for various reasons. Firstly, it provided scientists with a chance to investigate the diversity and composition of objects in other star systems, enabling a better understanding of the building blocks and formation processes of celestial bodies throughout the universe. By analyzing its composition and structure, researchers aim to decipher clues about the conditions and processes that shaped Oumuamua as it made its way across interstellar space. Here's what they found. Oumuamua takes the form of a rocky, elongated object resembling a cigar, with an aspect ratio that sets it apart from any asteroid or comet observed within our solar system. You see, comets are icy bodies that originate from the outer regions of the solar system, often in areas such as the Kuiper Belt or the Oort cloud. They are composed of a mixture of water ice, frozen gases, dust, and rocky material. Compared to the elongated and unique shape of Oumuamua, comets typically exhibit different characteristics in terms of shape and size. In general, comets tend to have a more rounded or irregular shape compared to the elongated appearance of Oumuamua. They often resemble dirty snowballs with irregular contours and varying surface features. As comets approach the sun and heat up, the ice in their nucleus vaporizes, releasing gas and dust particles. This process can form a cloud of gas and dust surrounding the nucleus, and sometimes a tail that points away from the sun due to solar wind and radiation pressure. Comets can vary significantly in size, but most cometary nuclei range from a few hundred meters to a few kilometers in diameter. The nucleus, which is the solid central part of the comet, is typically smaller and denser than the coma and tail. However, the size of comets can vary greatly. For example, the famous Halley's Comet, which returns to the inner solar system every 76 years, has a nucleus estimated to be around 15 kilometers in diameter. Some comets may have larger nuclei, reaching tens of kilometers or more, but for the most part, they all share a similar shape. The reddish hue of Oumuamua distinguishes it from these common comets too, exhibiting a color reminiscent of objects found in the outer regions of our solar system. This reddish tinge suggests a unique composition or surface characteristics. Notably, despite its close encounter with the sun during its journey, Oumuamua did not display any signs of a coma, so it was clear that this wasn't an ordinary comet, but something else entirely. One of the most intriguing aspects of Oumuamua's behavior is its non-gravitational acceleration. This is a sign of the presence of additional forces acting on the object beyond the gravitational pull of the sun. This phenomenon can be explained by two main factors. outgassing, and solar radiation pressure. Outgassing is something that happens when volatile substances, such as gases or ices trapped within the surface layers of a celestial object, vaporize and are expelled into space. When a comet approaches the Sun, the increased heat causes the sublimation of volatile materials present in its nucleus, leading to the release of gas and dust. But there's also solar radiation pressure. This is the force exerted by sunlight on objects in space. Photons, which are particles of light, carry momentum, and when they interact with a surface, they transfer a tiny amount of their momentum to it. While the momentum transferred by individual photons is extremely small, the overall effect of the enormous number of photons from sunlight can lead to a lot of pressure on objects. This pressure can push against the object and cause it to experience a slight acceleration. In the case of Oumuamua, the combination of its elongated shape and the radiation pressure from the Sun could potentially result in a non-gravitational acceleration. But that's not all. As Oumuamua spins on its axis, it displays significant variations in brightness, with a factor of 10 difference. This rotational period spans approximately 7.3 hours. This degree of brightness variability surpasses that of any known asteroid or comet in our solar system, acting as another point that highlights the unique nature of Oumuamua. As for the size, that's where things get a little more confusing. The size estimates have been subject to variation across different studies and observations. Several sources provide different insights into its dimensions, adding to the complexity of understanding its true size. According to a study from NASA's Jet Propulsion Laboratory, Oumuamua's spherical diameter is estimated to range from a possible maximum of 1,440 feet to a minimum of 320 feet. This study suggests that Oumuamua could potentially have a spherical shape, with a diameter falling within this range. On the other hand, NASA's solar system exploration offers an estimate that emphasizes the elongated nature of Oumuamua. It suggests that Oumuamua is highly elongated, up to a quarter-mile long, and potentially about 10 times as long as it is wide. This implies that Oumuamua has a significant elongation along its main axis, making it much longer than its width. However, a more recent study presents a different perspective, suggesting that Oumuamua is smaller than initially believed. According to this study, Oumuamua's size was estimated to be 147 by 144 by 24 feet when astronomers first detected it. This estimate indicates a smaller physical extent for Oumuamua compared to the previous studies. If there's one thing that's consistent throughout all of these studies, it's that Oumuamua is a cigar-shaped object, an object that needs thorough study to really figure out. And there was no better telescope than the Pan-STARRS 1 telescope for the job. Located near the summit of Haleakala on the island of Maui, Hawaii, Pan-STARRS 1 is a crucial instrument in the study of Oumuamua and other celestial objects. With a diameter of 1.8 meters, it forms a vital part of the Panoramic Survey Telescope and Rapid Response System, Pan-STARRS project. This collaboration involves the University of Hawaii Institute for Astronomy, MIT Lincoln Laboratory, Maui High Performance Computing Center, and Science Applications International Corporation. The Pan-STARRS project aims to conduct continuous sky surveys, utilizing astronomical cameras, telescopes, and a computing facility. Some people speculate that Oumuamua, the interstellar object that passed through our solar system, might have been propelled by a special type of engine or alien technology. They suggest it could have used a light sail to catch energy from stars and push itself forward. This theory posits that Oumuamua might be a piece of an advanced alien spaceship or equipment sent to explore other star systems. Proponents of this idea believe its journey through our solar system was part of a deliberate mission. Intriguingly, Oumuamua didn't have a tail or release gas like typical comets or asteroids, which some interpret as a deliberate choice to hide its presence, possibly using a propulsion method we don't yet understand. The reddish color and surface properties of Oumuamua are also noteworthy. If Oumuamua was indeed an alien spacecraft, its reddish hue could be intentional. designed with materials or coatings that interact with cosmic radiation and stellar energy to produce a distinct color. This reddish coloring might serve as camouflage, blending in with the reddish objects commonly found in the outer regions of star systems, thereby reducing the chances of detection. This theory imagines a highly advanced extraterrestrial civilization sending a reconnaissance mission to gather information about Earth and its ecosystems, with Oumuamua acting as a vessel designed to withstand interstellar travel and discreetly collect data. This speculative scenario also suggests Oumuamua's unusual shape and composition serve multiple purposes. Its elongated form could help it withstand cosmic debris and ensure stability during its long journey. Equipped with advanced sensors and communication devices, it could discreetly gather data about Earth's atmosphere,